Welcome back to Chempoetry. Today we are diving deep into the mathematical backbone of quantum chemistry and quantum mechanics, Hermitian operators. If you have ever wondered why observable like position, momentum and energy always yield real numbers when measured, the secret lies right here in Hermiticity. Let's break it down step by step. To check the hermiticity of any operator, we use the Hermitian adjoint or Dagger method, represented by the Dagger symbol. Mathematically, it combines complex conjugation and transposition. Based on this, we define two key terms. One is Hermitian operator, another is Anti-Hermitian operator. An operator is Hermitian if it is equals to its own adjoint. A dagger equal to A. Anti-Hermitian operator and operator is anti-Hermitian if its adjoint equals it negative. A dagger equal to minus A. Before we jump into example, let's look at the essential rules of dagger operation that will make your derivation a breeze. Double adjoint. Taking the dagger twice brings you back to the original operator A dagger equal to A. After that, linearity. A plus or minus B whole dagger equal to A dagger plus or minus B dagger. Then the constant factor. Constant A whole dagger equal to C star A dagger. Notice how the constant gets complex conjugated. Then product adjoint. A B dagger equal to B dagger A dagger. Remember that the order reverses. Derivative adjoint. D by dx dagger equal to minus D by dx. Then the position operator x dagger equal to x. Let's put these rules to the test with two crucial operators from quantum mechanics. First, the quantum momentum operator defined as px equal to iota h cot d by dx. Let us find its adjoint. Px dagger equal to minus iota h cot d by dx dagger. Breaking it apart using our constant and derivative rules gives us minus iota h cot star d by dx dagger. Since the complex conjugate of minus iota is plus iota and the derivative dagger is minus d by dx, we get iota h cot minus d by dx equal to iota h cot d by dx. The momentum operator equals px, proving it is Hermitian. Next, look at the 1D kinetic energy operator kx equal to minus h square square by 2m d square by dx square. Since d square by dx square can be split into d by dx into d. Since d square dx square can be split into d by dx dot d by dx bar, applying our product and derivative properties yields kx dagger equal to minus iota h cot square by 2m star d square by dx square dagger. Evaluating these steps was right back to minus iota h cot square by 2m d square by dx square, which means kx is Hermitian as well. Summary table of common differential operators and their classification. Notice how multiplying by I flips a differential operator's hermiticity status. Let's wrap up with the algebraic behavior of Hermitian operator. Sum and differences. The sum or differences of two Hermitian operators is always Hermitian. Multiplication. The product of two Hermitian operators is only Hermitian if they commute, like AB equal to BA. Commutators. The commutator of the Hermitian operator AB equal to AB minus BA is always anti-Hermitian. AB dagger equal to minus AB anti-commutators. Conversely, the anti-commutator AB dagger equal to AB plus BA is always Hermitian. To conclude, Hermitian operator form the absolute foundation of observable quantities in quantum mechanics, ensuring that we get real eigenvalues and orthogonal eigenstates in our calculation. If you find this video helpful, make sure to hit that like button, subscribe to Chempoetry for more physical chemistry tutorials, and leave your question in the comment below. See you next.